friends, welcome to B.TECH. In the unit 5 of LECA subject, now we are going to discuss about the linear ramp generator. So what is this linear ramp generator? What is the purpose of this linear ramp generator? We need to know. So simply we can say the linear ramp, we all know that the ramp signal will be like this. Okay. So for that we are going to connect charging. This one we can say as a charging path, and this one we can say as a discharging path. So charging and discharging will be done by using the IC 555 timer IC. So this signal will be just this shows like the linear ramp signals. Okay. For that we are going to connect the circuit. Here I am showing you the schematic diagram of our linear ramp generator. If you see, the first pin and fifth pin will be shorted, but in between that we are going to connect one capacitor, that is 0.01 microfarad, to decrease the noise over here. And the second pin will be connected to the sixth, and the second and sixth pin will be shorted with the sixth and seventh. Two, second, sixth, and the seventh pin will be shorted, and this will be given to the output ramp signal. And third pin will be given to the output Vout, and fourth and eighth pins will be shorted, and it will be given to the VCC output. And here I am going to connect one capacitor C3, and this will be connected to the VCC. And later on I am going to connect my transistor to the pin number 7 shorted point, and one pin for VCC and one pin for VCC, and the base will be connected to the variable resistors, and here I am going to connect one diode also. So to give the ramp signals, I am going to connect this type of structure over here. Okay, so if you are seeing this capacitor, so this is the capacitor which is going to charge and discharging in the form of a ramp signal. So we all know that inside the circuit we are having the threshold voltages like 2/3 VCC comparating voltages, and 1/3 VCC will be there in the internal circuit of the IC 555 timer. We are going to work with this 2/3 VCC and 1/3 VCC. Basically, we all know that the flip-flop output will be high starting. At the starting point, the flip-flop output will be high. If the output is high, then automatically what will happen? The charging path will be in the capacitor what we are having over here. This will be in the discharging mode. When it reaches up to 1/3 VCC, then the comparator 2 what we are having, so that the comparator 2 will activate, and then the flip-flop output, that flip-flop output will be low, means Q bar will be high, means the output, final output will be low, means it will happens that in the charging path, the capacitor what we are going to connect, this will be given in the charging mode up to 2/3 VCC, means the signal what we are using, this will be changed from 1/3 VCC to 2/3 VCC. So the highest limit is 2/3 VCC, and the lowest limit is 1/3 VCC. So this pattern will occurs by using this type of circuit diagrams. So for that reason, this one we can say as a ramp generator. So you can see this diagram. When the triggering pulse is applied, if you see this diagram, then you can find that statically, basically the output is high. So when I am giving the triggering pulse 0 volt, then automatically charging will come and discharging will move fastly. Charging and discharging will move fastly. Charging and discharging will move fastly, and charging and discharging will move fastly. So what will happen? The discharging time is less. Discharging time is less when compared to the charging time. So means TC is T charging is less than greater than compared to the discharging time. Means the discharging time is very less when compared to the charging time. So if you see this diagram, you can easily find that. So the ramp will be generated, the charging time is more when compared with the discharging time. You can find that in this graph. So like this it will happens. So this is the charging time, and this one we can say as a discharging time. The total time we can consider as a duty cycle. So the duty cycle, the T on, since the T on is greater than T off, means the timer on is greater than the T off, the waveform is not symmetric manner. So for that we are going to get the duty cycle. So the duty cycle is defined as the ratio of on time to the total time of one cycle. Ratio of on to the total time of one cycle is nothing but the duty cycle, we can say. Means the formula is nothing but the percentage D equal to work done by total time multiplied with the 100%. So the charging time of the capacitor will be here in the diagram. Here in the diagram, I am connecting two resistors, two variable resistors. So I can say these two as RA and the RB. If you are going to find out, if you are going to find out the charging time, then we can say we already having the formula that TC equal to 0.693 multiplied with R into C. Right. So this is the value we are having for the charging time. So this is equal to 0.693 multiplied with RA plus RB multiplied with C. So like this we can say as a charging time. If we are going to the discharging time, so this is also called as 0.693 into R into C. The discharging time will be RB only. Means 0.693 multiplied with RB multiplied with capacitor. If we are going to the one clock cycle or one cycle, then we can say that T equal to TC plus TD. Equal to that multiplied with 0.693 multiplied with RA plus 2RB into C. So this is the total one cycle, we can say. So here we are adding the charging time multiplied added with the discharging time. So this is nothing but the total time we are getting. So now we are going to find out the duty cycle. So duty cycle, percentage of the duty cycle equal D equal to percentage D equal to TC, charging time by total time multiplied with 100%. So means 0.693 multiplied with RA plus RB into C divided by 0.693 multiplied with RA plus 2RB with C into 100. So this 0.693 will be cancelled, C and C will be cancelled. Means RA plus RB divided by RA plus 2RB multiplied with 100. This is nothing but the percentage of duty cycle. Okay. Next, we are going to find out the frequency of the oscillations. F equal to 1 by T. We all know that frequency is equal to 1 divided by the reverse to the time. So 1 divided by T equal to 1 by 0.693 multiplied with RA plus 2RB into C. So this is nothing but the F. Okay. So this is 1.44 divided by RA plus 2RB into C Hs. So here I am going to show you the schematic diagram of the our linear ramp generator. So we all know that this pin 5 will be connected to the capacitor to decrease the noise, and 2 and 6 will be connected, and 7 will be connected between RA and RB. Here I am connecting the capacitor which we are going to charge and discharge according to the system diagrams. Okay. Thank you.